Hello guys, in this video I'm going to show you how to solve search in a sorted infinite array. So given an infinite sorted array or an array with unknown size, find if a given number key is present in the array, write function to return the index of the key if it is present in the array, otherwise return -1. Since it's not possible to define an array with infinite size, you will be provided with an interface array reader to read elements of the array. So we're given this infinite array class, right, with get method takes in index and return the number. So if the array size is smaller than the index, right, it will return integer mark values. In JavaScript it is infinity. So if the index text in is greater than array size, which means it out of bound the array, return infinite, right? Otherwise return the number at that index. So for this problem, it's pretty much the same as binary search problem, except the fact that the array is unknown size. We don't know the size in advance. For binary search, we must know the array size in order to find the middle index, right? We need to know the array size in order to find middle index, right? And at each step, we try to cut off half of the search space. But for this problem, when we don't know the array size, so is there any way that we can still find the middle index? Actually, the middle index can be calculated from left and right, right? You must know left and right of the space that we're searching for. Left and right is not necessarily the first and the last of the array, right? So one way to find the search space for the key, right, is to gradually expand the search space until we find a area, a subarray where the key should be in, right? So because our array is sorted in ascending order, so for example, in this for this input, right, we need to find 16. So we're gonna start left and right here, right? So as you can see, the size of the search space is now 2, right? We have 2 numbers. It's clear that we can clearly see that 16 is not in this subarray, because 16 is greater than the largest one in this subarray, which is 6, right? So it should be on the right. So we're done with this area. We will expand it to the right, right? So the new lab now will be here. But what is the right? The right, because the previous side, the side previous search space is 2. So while expanding to the right, we want to double the size, right, of the search space. So we want the size of search space should be 4 now. And because the size is 4, the left is here. Now we update the right. It will be here. 2. Okay. So again, is 16 in this search space from left to right? It is no, because 16 is greater than the largest value, which is 14. So it should be on the right. So we again expand it to the right, and we want to double the size of search space to 8, right? So that's how we're gonna limit the search space, right? So let's try to code it down. So we're gonna find the search space first. We need to find the left and right, right? The bound of search space, the left bound and right bound of search space. So we started from left is 0, right is 1. So as long as the key, right, the key, which is the target value, is still greater than the rightmost value of the current search space, which is infinite array, we get at index right. It means its search space is on the right of the current bound. So we expand the current bound to the right. So you want to remember that I save the size of current bound, current is right minus left plus 1. So Okay, so we open the bound to the right. It means the new left will be right plus 1, and the new right will be what will be the current right plus side of the current bound times 2, right? We want to expand, right, the bound side. So when it exceeds this loop, it is when the key is less than or equal to the rightmost value. So now the key value is within the bound, which is which can be determined by left and right, current left and right. So now we just we start to do normal binary search. Return binary search. Let's abstract the logic here. So we have infinite array. We have the bound, which is left and right, and the key. Right here is what we need to find the key. So functions binary search array left right key. So for binary search, wanna loop as long as left is still less than or equal to right. Want to still keep searching, right? So want to calculate the middle. Middle can be calculated by left plus right minus left divided by 2. This can be returned a decimal value, so we want to round it floor using map.for. Okay, the middle index here, so there are two cases here. If the key, which is the target value, is equal to array at index middle, I'm gonna return the index, which is middle. Okay. Else if key is greater than or array get middle, and then gonna eliminate everything on the left, right? We reduce the search space by half, right? So in order to do so, wanna reassign because the key is on the right side middle, wanna reassign the left, right? Left pointer. So the left will be middle plus 1. Else, in the case when keys is on the left with middle, so we reassign the right pointer is middle minus 1. Okay. If we exit the loop, and it means we can find a number in the array that equal to key, so we return minus 1. Okay, just 11 4. Okay, so that's it for this one. Let's make sure that it ran our implementations here. Okay, so it works, right? So that's it for searching in a sorted infinite array. So thanks for watching. See you in the next video.